Hello, this is Trusting Islander. In this second video, I will be continuing what we started by discussing about algorithms. Now, algorithms are very interesting because they allow you solve a problem by following a particular sequence of steps. Now, sequence because you must follow them in order. If you fail to do so, you'll get a different result. Now, this link shows you a collection of algorithms. They cover various fields of endeavor. But the algorithm we will be looking at for this course will be Euclid's algorithm. Now, Euclid's algorithm shows you how to find the HCF of two numbers in a mechanical fashion. Mechanical because at the end of the day, an algorithm is a mechanical solution to a problem. Now, the way to do this would be to use the modulus function and find the remainder. So I'll give you a hypothetical example. If we have two numbers, and I'll call this step number, first number, second number, and remainder. And in your first step, if you're given two numbers, 1 and 6, okay, let's use 1000. Now the goal with this would be to find the remainder. Now what you do with this is the modulus of this, and I can just quickly show you that in idle, I will search for idle here. Please, if you're using any mobile solution for this, you can also use that, but in my case I'm using idle. So what I'll do here is this. I would say 1000 modulus 625. So let me just quickly bring that in. So 1000 modulus. Now this operator here is for modulus. So 1000 modulus 625, and that will give you 375. Now the beautiful thing about this is if we say 625 modulus 375, we get 120. So the way it works is we'll put 375 here. Now it's reductionist in approach. So what happens is this comes here and this is now 625. This comes here, this is now 375. This comes here and this is now 250. Now for step 3, we'll put this, we'll bring this here, we'll say 375. Bring this here, we'll say 250. Come here and we'll say 375 modulus 250. Now the answer will be 125, and so we'll come here, we'll say 125. Now step 4 would say bring this here, 250, 125 and 0. So at the end of the day, our stopping condition is when our remainder is 0, and at each stage you continue swapping the values this way. So you go here, you go here, you go here until you get to the end. I hope this explains Euclid's algorithm. In the course of this training, we will be looking at how to write a program for Euclid's algorithm. It will be the basis of covering everything in the curriculum. Thank you very much for watching.